Hello everyone. Today we will learn integration by substitution, another method which is next step after learning the formulas. In our previous lessons we learned the integration by basic formulas, but sometimes it's not enough. And you can directly apply these formulas. So we use integration by substitution when the integral contains a composition of function. There is a function inside another function, just like here we have x squared inside 2x cos. And before we apply formulas, we need to substitute it. We can identify that one part of the integrand is the derivative of the inner function. So we use substitution when we find derivative is present, so they can nicely cancel out. So we can simplify them, and then we can bring back the integration formulas. So it's very useful to know this power rule for derivative. I showed you this in the previous class, but you should remember about this, because without it, it will be impossible to proceed further. Okay, we also talk about inner function, some simple inner function, just like here is e to the power of 2x. You know that if you have e to the power of x, it equals ex. But if it's 2x, you cannot apply that formula. So I'm just showing you simple substitution can lead to the same solution. Right? We have a half of e to the power of x plus c, exactly as we see it here. And we obtain it by substitution. So when we solve by substitution, we need to find the inner function which we replace by u or another substitution. It could be u or t or d, whatever you like, but the most common is probably u. So this function 2x, which is inner function, is substituted by u. Then you take derivative of u, right? Here you have you take the derivative, and you know from the power rule for calculating derivatives, you know that it will be 2. Derivative of 2x is 2, and du actually is derivative of u times dx. So after we write derivative here, we need to write dx. It's crucial. It's important for further calculation. So then we solve for dx. And we know that the dx, you have to divide it by 2, equals du divided by 2. And now you can solve the integral. Instead of power of 2x, you write to the power of u and du2, because dx is the same as du over 2. And you can move this 2 out of the fraction before, and it will be a half of e to the power of u du. Then it is a half to the power of t, a half to the power of e to a half of e to the power of 2x plus c. Okay, this is the answer. So just show you step by step. First, you do substitution. You find what is du, you find what is dx, and you write dx as du, and you can simplify. Then you substitute back to the original value. This are another examples. You can follow how to do it. So 4 cos 4x. So inner function is 4x. So this is the first step. What we do, we find what is u equals 4x. We find du. Then we solve for dx. And here we've done the calculation. So as you can see, you can cancel out 4. And what is left is only cosinus u. And then here is still integration, but after we do integration, cosinus changes to sinus. So you have sinus u, but you substitute u as 4x back because it was originally 4x, and you get the answer sinus 4x plus c. Another one a little bit more difficult, you can see it here. U will be 40 minus 2x squared here. You calculate du, which is derivative of u, derivative, and times dx. Then you do it this way, and as you can see here, we simplified minus 4 with 8x, so 8x becomes minus 2, x cancel out, we remove x, Then we have minus 2u du, and square root can be written as a half exponent. So u to the power of half is the same as square root u. So we write it this way to apply power rule, because we want to apply power rule. That's why it's important to write it as exponent, not the root. So you see the calculation, half plus 1 is 3 halves over 3 halves here. Then division, you simply change it to multiplication, so it becomes minus 2 times 2/3. You multiply by reciprocal, and it becomes negative 4/3 times u to power of 3 halves, and substitute u with this 14 minus 6, and you get your solution. Another case a little bit more important, so you should know this rule. It's very important. It will be present in many calculations, that a to the power of negative n equals 1 over a to the power of n. That's how we can replace exponent with 1 over number and exponent. So here we do, first what we do again, we solve for dx, we find what is u. U is 2 plus x squared, we choose this. We calculate du, and look what we are doing here, we calculate in fraction. X to the power of 3 over 2 plus x squared becomes x to the power of 3 over u squared. Much easier to perform calculation. What is very cool here, that you have 1, right, because we simplified 4x to the power of 3 with x to the power of 3. So this cannot disappear, but that will be 1. 1 will be left here. And we need to write 1 over u squared, which we later, using this formula, we write this as u to the power of negative 2. So 1 over u squared equals u to the power of negative 2. This is important, this transformation. Because again, we use it to apply the power rule, right? We can apply power rule later. So we've got after applying power rule, right, because we need to write minus 2 plus 1, this is power, minus 2 plus 1, so it becomes u to the power of negative 1 over negative 1. This is application of power rule. And then we have something like that. And you know that u to the power of negative 1, again, this is the same formula here. It becomes 1 over u. So instead of u to the power of negative 1, we substitute back to the 1 over u. And divided by 1 is 1, so become negative 1 over u, just like here. And we can substitute back to the original value, which was 2 plus 4x squared, but here is times 4. The last example, still we're going to use the same rule, which is very important, but which is what we also need to know is that derivatives of sinus x equals cosinus x, derivative of cosinus x equals negative sinus x, which is different than for integration. So this table you can memorize. So what did we do here? U is 1 plus sine x, du is cosine x dx, solve for dx, and we have du over cosine x, and this one we used to simplify. Cosinus was removed and will be 1 left, so we have integral of 1 over square root u. And we can use this rule, that square root is the same as u to the power of 1/2. We change the square root, so we could apply a power rule. We are applying the power rule here. And again, we also transform this 1 over u to the power half. We use this rule. We use this rule that it equals u to the power of 1/2 to negative 1/2. And then from this transformation, we will be able to apply the power rule. And you substitute back this value. Okay, so what it shows you that in the first 2 classes I was teaching you about these formulas, but as you will see in these examples that substitution helps you to simplify the integral when you cannot directly use a formula. And what it shows that thanks to these modifications, we use substitution, we cancel out certain part, then we can apply some exponent rules, do some algebraic transformation, and then it becomes much easier to solve. Okay, so hope you find this video useful. That's all for now. Thank you very much.